So, does anybody remember what a tangent line is? What's the difference between a tangent and a secant line? Yeah, the tangent's just on one point. So, for example, if I were to draw a curve, okay, let's say I wanted to know the tangent line at this one single point, it kind of hugs the curve. It follows the curve parallel and only touches at one point, whereas a secant line requires 2 points. So the one example we're going to do today, I think, might be the same equation from yesterday's notes, but it says determine an equation for the tangent line at x equals 4. So you only need one x value. You do need a point. I think the worksheet gives it to you again, but you do need a y value. So real quick, how would you figure the y value out if they just give you the x value? Yep, just simply plug it into the equation and it will give you the y value. Now, let me ask you a little bit more advanced question. How would you find the slope if you only give it 1 point?
I know, but how'd you do 7 over 11?
So how would you find m, though? You take the derivative, okay? I know that I've mentioned it a lot, but we haven't used that concept a lot. But the derivative is the slope of the tangent line. It's the same thing. So we're going to take the derivative of this equation and then plug in x equals 4, and that gives you m. Let's take a look at what this graph looks like. I think it's the same graph as yesterday, but as you can see, we're trying to find a tangent line which would go this way. It would touch the graph at 4. So in order to find the slope of that line, we need to take the derivative of this equation, won't be too hard, and then plug in 4. That will give us the slope of that tangent line. So ultimately, we're trying to find the equation for this orange line. Okay, so, but first of all, like you said, to figure out the y value, you can quickly plug in the x value into the original equation. So you're going to get 1/2 times 2 squared, right? Which is 1/2 times 4, right? Which equals what? 2, right? So that confirms what we just looked at, basically. That point on the graph is 4, 2. You need that in your y equals mx plus b, right? You need a y and an x value. Now, again, to solve for slope, though, you got to take the derivative. Plug that x value in, and it'll give you the slope value. I just did it in one step. But yeah, plug in the x value and then figure out what the y value is. I just did that. Y equals 2. So that's your point, is 4, 2.
Maybe we're still doing the...
All right, but the next step is to take the derivative of the original function. I'm using the power rule. The original power is 2. I'm taking that 2 and moving it out front and then multiplying by 1. I'm using the constant multiple rule. Since it was 1/2, I'll take the 1/2 and multiply by the derivative. Now the derivative of the inside, we do have to use... Please keep it down.
Oh, my bad.
The derivative of the inside, derivative of x is 1. So it won't really affect it for this problem, but just make sure you use the chain rule since it's in parentheses. 1/2 times 2 is 1. Anything to the first is itself, so basically the derivative is x equals 2. Now, this used to confuse me when I was a student, so I thought I'd mention this. This does not give you an equation for the tangent line. This is an equation for the derivative. So you have to plug the x value that they gave you into the derivative equation to get the slope. So what x value did they give us? They give us 4, so we're going to plug 4 into the derivative equation. So 4 goes here. Okay? So you get 4 minus 2, which is 2. This, might as well write it, is your m value. So again, take the derivative and then plug x into the derivative to get your m value, or your slope. That gives you the slope of that tangent line we looked at right here. So that means the slope of this line is 2. Okay, so for step 5, you'll just write m equals 2. Because when we plugged in 4 into the derivative, we got 2 back. All right, so now you're going to write what? Y equals mx plus b, right? You have m, you have y, and you have x. You're still solving for b like with secant line. So I'm plugging in 2 for y, which is my y value I figured out. plugging in 2 for m, that's the slope we just found, 4 for x. So we get 2 equals 2 times 4 plus b. So you're going to get what? 2 equals 8 plus b. Then you're going to subtract 8 from both sides, and you get b equals negative 6. So finally, what do you think the equation for that line is going to be? Y yeah. Yeah, y equals 2x minus 6, exactly. Okay, so plug in b and m into the equation, and you get y equals 2x minus 6, which is the equation for that line.
Negative 0.375.
All right, here we can see it down here. The equation for this line is y equals 2x minus 6, meaning it'll cross the y-axis at negative 6, and it has a slope of 2. So y equals 2x minus 6. So it's still a line, just like the secant line. It just touches the graph at one point. That's it. And then next, we'll talk about normal line. Not today, though.